So welcome to all of you. Last time we have seen theoretical part of the function. Okay. So in this video lecture we will see some problems on the function. So first we will note that, so suppose this is a relation, not a function. F from A to B is a relation from A to B, such that the number of elements of A is m and number of elements in B are n. Then you know that the number of elements in A cross B is m into n. Okay, that is mn. So you know that the subset of any subset of A cross B is a relation, right? So how many relations we can form from A to B? This is the problem. So how many numbers, how many relations we can form with the help of A and B? That means from A to B. So the number of relations from A to B. So there are 2 raised to mn relations we can form from A to B. Okay, and number of relations are only A. That is what, if you want equivalence relation, we have defined this is only on the one set. So there are what, 2 raised to m square. Same here. What your A cross A is what, m into n. That means m square. So that means what here, 2 raised to m square relations we can form on the set A. So then you know that relation is a function under some conditions. Every element of A is related to unique element of B. Then we say that relation is a function. So how many functions we can form from A to B? So see, the number of elements in B is what here, right? So this is what the number of functions from A to B, and functions from B to A are what, m raised to n. Okay, so this is the fourth one. No, so number of functions from B to A are m raised to n. B to A, so A should be at the base, and here what, number of elements will be at to the power now here. Okay, so notice, right? This is a very important for objective questions. These 4 points are very important for the objective type questions. Okay. Now let's see some problems on it now. Consider example 1. Okay, example. Consider the functions f from z to z. This is what, the set of all integers. Okay, and g from set of natural number to integer defined by f of x is equal to g of x is equal to x cube. Now the problem is that each f is equal to g. So you know that two functions are equal. So what here? So see, they have defined f of x is x square, g of x is also x square. Okay. So problem is that each f is equal to g. Whether these two functions f and g are equal or not. Right. Now see, f is from what, integer to integer, and g is from natural number to the integer. So you know that two functions are equal if their domain and codomains are equal. Also for any x belong to domain, your f of x is same as g of x. Then we say that f is equal to g. So first is what, important thing, what, domain and codomains are equal in the definitions, right? And for all x, because domain are both the domain of both the functions are same, right? So x is in the domain and f of x is equal to, so this is true for every x in the domain of the f and g, right? So then f is equal to g here. Now see here, the clearly you are here, domain and codomains are not same. So their codomains are same, but their domains are not same. Okay. So solution f not equal to g, since domains of f and g are not same. Okay, so whether these formula are same but domains are not same, that means these two functions are not equal. Okay, so next, second example we take. Second example. Let f from R to R. Let f from R to R defined by f of x is equal to 3x plus 2 g from R to close interval 0 to infinity be defined by g of x is equal to 3x plus 2 are f and g equal. See here, f of x is 3x plus 2, g of x is also, so formula of f and g are same here. Okay, so but what is the definition of the equality of the function? So first point is what? The domains of f and g are same. Second point is what? Codomains of f and g are same, right? And what? The formula need not be same. Only what here? F of x is same as g of x. F of x is same as g of x for all n belongs to domain. This is the condition. Formula may or may not be same, but this what? F of x is same as g of x. That means what? If you find f of 2, so v1 and g of 2 both should be equal for any x now. For every value of the point in the domain, so f and g have the equal value. So then we say that functions are equal. Now what happened here? Your domain are same now here, but the codomains are not same, right? So solution f and g are not equal since codomains of f and g are not same. Only this is the answer. Okay, so codomains are not same, right? Whatever this formula may be same or may not be same, but here what? Domains are not same, functions are not equal. Codomains are not same, functions are not same. Okay, even though the formula are same. Okay, so we'll take the next example. Let f from z to z with the set of integer, okay, z to z defined by f of m is equal to m plus 1. What is range of f? What is the range of f? Okay, solution. Okay, so you know that the range of f means what? Suppose this is your x, this is your y. Okay, so the elements of the codomain which have the pre-image, that means if here y is there, then should exist x such that f of x is equal to y. Okay, so you want to find such y. That means what? If your y is in the domain, then should exist x belongs to in the codomain in the domain such way that f of x is that. That means what? The elements which have the pre-image, elements of the codomain which have the pre-image, that you want to find. Okay, so that means what? Suppose this is what? N. Okay, such that f of m is equal to n, such that simply we'll write this what? So this should be, we'll find such f of m such that m belongs to z. So that means what? M is in the, this m is in the domain. Note that this is what? Domain. Because what here? Domain and codomains are same here, right? But this m is with z, that means it is in the domain, because f of m can be applied only on the elements of the domain. So this m is in the domain of the f. So what is the f of m? F of m is m plus 1. So this is what? M belongs to z now. Okay, so now m is z, m plus 1 is also integer now. Take any here, m for any all m. This is what? For all m. So and plus 1. So it is same as the set z now. What? So range of this word also z. Okay. Now second problem. Okay, this is the example. Okay, so next example. Let f from n to n, natural number to natural number now. Natural number to natural number defined by f of n is equal to, or you may write f of m is equal to m plus 1. What is range of what is range of f? What is the range of f? Okay, so we'll solve this. Solution. Let f from n to n be defined by f of m is equal to m plus 1. So they may be given f of x is equal to x plus 1 or whatever this. Okay, so now range of f. So this is the standard notation for range of f is equal to what? F of m such that m belongs to n. So this is now your domain now. Okay, so now what is m? So m is what? F of m is what? M plus 1. M belongs to n now. So that means m is natural number. So it is start from 1, 2, 3, 4. If you add this what, then we get what? This is 2, 3, 4, dot dot dot. All the natural number, right? So now here 1 is not there. The set of natural numbers started from 1. Okay. So all natural numbers are there except 1 now. So you may write this as what? N minus singleton 1. Okay. So that means all natural numbers are there except 1. Okay. So if you can write this n minus 1, this is what? Right. Otherwise keep this as it is now. So this is the natural number, set of the natural number minus, that means what? This is the range of f is what? The set of all natural number except 1. Okay. So you may write, if you are not able to write this, don't write this, just keep this as it is. Okay. Next, let fg from x to y, fg from, where both domains and codomains are equal, if the range of f is same as the range of g, the range of g. Can we conclude f is equal to g? Can you conclude f is equal to g? Okay. Solution. Let f from r to close interval minus 1 to 1 and g from r to minus 1 to 1. F of x is equal to cos x. G of x is equal to sin x. So now you know that the cos x lies between minus 1 and 1, sin x also, right? So here what? Range of f is same as range of g. See, if it is not possible to prove f is not equal to g, so take a counter example such way that range of f and range of g are same, but f of x is not same as g. So here what? So f is what? F not equal to g. Since what? F of 0 is what? Cos 0 is 1 and g of 0 is what? 0. That means what? F of 0 not equal to g of 0. So when the function is equal, if you apply on the same element, so they should be equal. So f applied on 0 and g applied on 0, they must be equal. But here they are not equal. That means your functions are not same. Okay. So but the range are same, right? Range are same, domain are same, codomain are same, right? So but also, so we cannot say that the functions are equal, right? So domains are same, codomains are same, the range are also same. So that does not imply that the functions are equal. So this is the better example. F of x is equal to cos x and g of x is equal to sin x. So here what? Domains are same, codomains are same, and range are also same, but these two functions are not same, right? So this is a very nice example. Such way that domains are same, codomains are same, range are same, but they are not equal. Okay, so this is very nice example. Let x is equal to ABCD and y is equal to 1, 2, 3. Which of the following are functions, find the range of each of the relation which are functions 1 F A1. Any subset of x cross y is a relation. So you want to determine the relations are given. So you want to determine whether they are functions or not. Okay. So this is what B2, P2, C2, D3. The second example is that G is equal to A1, A2, B3, C2, D1. And third example, H is equal to A1, B2, C3. Okay. So these are the three relations. You want to determine which is it a function? Okay. So solution 1. F is equal to A1, B2, C2, D3. How we can write? Just we will write this in the form like this. Okay. So A, B, C, D, and this is what 1, 2, 3 now. Okay. So this is your F. So what is this? A is related to 1. Just A is related to 1. B is related to 2. C is related to 2. Okay. Now D is related to 3. Now see, every element of this capital X and this is the capital Y. So every element of X is related to unique element of Y. Okay. So every element of X is related to unique element of Y. Now here see, B and C have the same image. Doesn't matter, but B is related to only one element of B is related to only one element of the Y. C is also related to only one. So they have the same image, but it has a unique image now. Image of B is what? How many images of B is there? Only one image is there. Image of C is also only one here, right? So the images may be same. Doesn't matter this. But what here? So every element have unique image. If B is related to again B is related to 3, then this will, because what, B is related to 2 elements then, right? So this will be not a function. But here what? So the images may be same now here, but the image should be the unique. Okay. So if every element of X is related to unique element of Y, therefore F is a function. So if you are not able to write this, right? So just write F is a function. Just write Venn diagram like this. Okay. So we'll now write second. Okay. So directly I write this. You write this one given that G is like this. So this is your X. Just draw the Venn diagram so that you will be able to check whether that is a function a, b, c, d. Then this is what 1, 2, 3. Okay, so now this is your G now. This your relation is what? G now. Okay, so A is related to 1. A is related to 1. A is related to 2. A is related to 2. B is related to 3. B is related. C is related to 2. D is related to 1. Okay. Now here what? G is not a function because what? A is related to more than one element. Right. So that means what? So this is not G is not a function since A has two images in Y. A has two images in Y. So that means G of 1 is 1, G of A is 1 and G of A is 2. So that means what here? So A has two images. So A is not related to unique element. Right? You may also write this word. A is not related to unique element of the Y, element of the Y. So therefore it is not a function. Or A is related to two elements of Y. So therefore it is not a function. Okay. Now we'll take third one now. Okay. So for third one. So now we'll draw this third one solution like this. So this is your X, this is your Y, this is your H now. So this is what? A, B, C, D. 1, 2, 3. Okay. A is related to 1, B is related to, C is related to 3. Okay. So is it a function? So note that what here? Every element of the domain is related to unique element of the codomain. Right? That is the definition of the function. Now here what? D has no image. So this is not a function. H is not a function since D is not related to any element of Y, or D has no image. Simply you can write since D has no image. Okay. So this is very simple now. So I hope that you understand this one. So how to check whether the relation is a function or not. Okay. So this is very nice example. So you can check whether that relation is a function or not. Okay. We'll take the next problem. Let A is equal to A.B.C. and your B is equal to 1, 2. Find all possible relations from A to B. Now this is very important. A to B or B to A. This is very important. A to B. Which are functions? Okay. Solution. So you know that if F is from A to B and number of element in A is M and number of element in B is N. So how many functions you can form? N raised to M. This is what M. Okay. N raised to M functions you can form from A to B if the number of elements in A are M and the number of elements in B are N. Okay. So now here what number of elements A are 3 and this what? So that means what? 2 raised to 3. You want from A to B. That means B raised to A. Number of element in B is what? 2. Number of element A is 3. So this is what? 8. So there are 8 functions you can form from A to B. So we'll check this. What? Solution. So A is equal to A.B.C. Okay. So and B is equal to 1, 2. Okay. So we'll write one function. You may write with the help of Venn diagram, or you may write this. What we will write that 8 functions now. This is what F1. This is A to B. So this is what A, B, C. So this is 1, 2 only. Okay. So I will take all images are 1. Okay. This is the one function. See here, every element of A is related to unique element of B. This is the function. Okay. No matter the images are same here, no problem for that. But image should be the unique now. Okay, so now this is your first function. You may write this function as what? A1. This is F1 as, you may write this F1 as A1, B1, C1. Okay, so this is your first function. We'll write the second function now. Okay, so this is what? A, B, C. This is what? 1, 2. So now we'll write second function. We'll shift all this A, B, C to 2 now here. Okay, so you may write this F2 is equal to what? So A2, B2, C2. This is the function. This is the function. You may write like this. Okay, so now, okay, so now this is F3 will write F3. Okay, so this is A, this is B, this will write F3. This is your A, B, C, and 1, 2 only. What we'll do? We'll take the image of A and B are same and image of C is 2. Okay, this is also a function. See here, all these are 3 are distinct functions here. We have to form such 8 functions now. We are not writing now your F3 is like this. Okay, you may write this one. F3 is equal to this one A1, B1, C2. Okay, so now we'll write the fourth function. This is what? A, B. So this is A, B, C, 1, 2. So this is now your F4. Okay, so what we will do? So A, B, 1. What we will do? A and C are image of A and C are 1 now here, and we will shift B to 2 now. This is your fourth function. Okay, so you can write this F4 as what? A1, B2. This. See here, all are distinct now here. 3, 4. Okay, so now we will write the next possible function. So that is what? F5. So this is A, B, C, 1, 2. This is your A, this is your B now. So what we will do here? Here what? So I will take the image of B, A as 2 now, and we will shift this image of A is 2 now here. So we have taken what here? Image of C is 2. Second what? Image of B is 2. And now third what? Image of A is 2 now here. Okay, and we will shift this what here. Okay, right? So now what we will do now? Image of C is 1. So this is what? Fifth function. We'll write out sixth function now. Okay, so this is what? A. So this is A, B. So this is F6 now. Okay, so A, B, C, 1, 2. So what we'll do here? See here, image of A. We'll take the image of A is 1. Image of A is 1, and we'll shift B and C is at 2 now. Okay, so this is not here. Okay, now what we'll do now here? We'll take image of, so this is what? Okay, so we'll write this what? This is your A, this is your B, this is your F7 we have to write. A, B, C. Now this is what? 1, 2. So now here what? We have taken image of A is 1. So we'll take the image of B is 1 now. Image of B is 1. Okay, and we will shift for A to this here. Okay, now next what? We will take image of C is 1, and that means our last function. So this is what then? F8 now, and this is the last function. This is what? A, B, C, 1, 2. What we will do? What we have taken here? Image of C, B is 1, right? So we will take now image of C is 1 now. Image of C is 1, and we will try this A and B is 2 now here. Okay, so now here see that here. This is also all these are 8 distinct functions you will write. Okay, so this is also a very nice example to form a function from A to B, right? So these are all a subset of A cross B, but they satisfy and some conditions what every element of A is related to the unit element of B. Okay, so this is very nice examples. We have formed all 8 distinct functions. These are all distinct functions. See here, no one is the same here. See here, image of 2 here. See, image of C is 2 here. Image of C is 2 for here what? Image of C is 2 here. But image of A is also 2 here. The image of A is not 2 here, right? So image of B is here 2. Image of B is here also 2. But image of C is also 2 here. So all are the distinct functions here. Okay. So I hope that you can form. This is what, suppose 1, 2, 3 is there. So then 3 to the power 3 is what? 27 functions. So try to find if there is what? B is equal to 1, 2, 3. Try to find that 3 to the power 3. That means what here? 27 functions. Try to form such 27 functions for your knowledge. Okay. For practice, you can do this. What? Take elements of B is also 3 now. Or take the image of take A is equal to AB and write this one C as 1, 2, 3 now. See what happens then. Okay. Okay, so we'll write the note. Note. Injective function. Injective function. The, you know that injective function is what? 1 function. 1 function. Okay. So how to prove that the function is 1, right? So we'll write two notes now here. Okay. So let f of x is equal to f of y. This implies that x is equal to y. Okay. So what we'll write is what? If f of x is equal to f of y implies that x is equal to y, then f is 1 function. F is 1 function or injective function. Now second, if x not equal to y implies that f of x not equal to f of y, then f is 1 function. 1 function. Then f is 1. This is also a definition. So you have to write what? Let f from x to y be a function. Let f from x to y be a function. If if x not equal to y implies f of x is not equal to f of y, then f is 1 function. This is the better definition of the 1 function. Okay. So now also if f from x to y is a function such that f of x is equal to f of y implies x to y, then f is 1 function. So if you want to prove f is 1 function, so take f of x is equal to f of y and prove that x is equal to y. Or take what? X not equal to y, show that f of x and f of y are also not same, right? So both the way you can prove the 1 function. So this is the better now. Among these two, this is the better one. If you want to prove f is injective function, so just take f of x is equal to f of y and prove that your x is equal to y. Okay. So we'll take the example on this. Let f from R to R defined by f of x is equal to twice x plus 3 is f is injective. So you have to determine whether this function is injective. That means whether this function is 1 or not. Okay. Solution. Given that f from R to R defined by f of x is equal to twice x plus 3. So let f of x is equal to f of y. So if you are able to prove x is equal to y, then your function is 1 function or injective function. Okay. So f of x is equal to f of y means what? Twice x plus 3 is equal to twice y plus 3. Your 3 get cancelled. So this is what? Twice x is equal to 2 is not equal to 0. You can cancel 2 is equal to, right? So what? You have taken f of x is equal to f of y and we get x is equal to y. That means your f is injective. Therefore f is injective. Okay. So the problem is over. Okay. Now we take the next problem. So here what? Domain and codomains are very important now here, right? So if you want to prove it is injective, so your domain plays very important role to prove whether it is injective or not. So it is very important for domain and codomains are very important here. Okay. So we check this example so that you will understand how the codomains and domains plays the important role to prove that f is injective or surjective. Okay. So let f from n to n now. F from n to n defined by f of n is equal to n plus 2 if n is odd, if n is odd, and this is twice n if n is even, thus is f is 1 1, is thus f is 1 1. Okay, solution. Given that f from n to n defined by this. Now this is a step function. If your n is odd, this is natural number. So natural numbers are 1 2 up to infinity. We don't know the last number. So that means if n is odd, then the value is what? N plus 2. That means n goes to n plus 2. And if n is even, then it goes to twice n, is double of that one. Okay. So you have to check the function 1 1 or not. Okay. So okay, let f of n is equal to f of m. Okay. So case 1. Both m and n even. Both m and n even. First we will take m and even. We'll take m and n odd, and we'll take one of them is what? m and n are not both even. That means what? One n m is, we'll take n is odd and m is even, right? Or vice versa then. Okay. So there are three cases now. So m and n are even. So if they are the even, then value of the function is what? Double of that one. Twice n is equal to twice m. Okay. So n is equal to m, right? So if m both are even, then we get n is equal to m. Okay. Case second. Both m and n are odd. If they are odd, then f of n is what? N plus 2 then. N plus 2. And f of m is what? M plus 2. Again this is what? M is equal to n. Right? Okay. Case third now. M is even, n is odd now. We'll take m even and we'll take n odd. Okay. So if m is even, so n is what? Odd now. If n is odd now, the function is what? N plus 2. Now what here? F of m. Your m is what? Even. If n is even, then this is what? Double of that one. This is what? Twice m. So what? M not equal to n, or n not equal to m. Okay. So now case 4 will take. Case 4. So here what? M even and n odd. So we'll take m odd and n even now. See, all cases are there now. All cases are here. Both m and n even, both m and n odd. One of them is even, right? And other is odd now here. Okay. So m is even. We have taken m if m is even and n is odd now. Here what? M is odd. So now here what? F of n. What is your n? N is even. Then this is what? Twice n. Okay. So if m is odd, so then this will what? Oh, here what? So m is not equal to n, you cannot say this. Yes, m not equal to n. Okay. Now here what? M not equal to n. F of m is also not same as f of n. No problem here. Twice n is same as what? M plus 2. Again here what? F of n not equal to f of m. So note that your f of m not same as f of n. Your x, m and n are not equal. F of m and f of n are also not equal, right? So therefore f is 1 1 function. See here, m and n are not same. If even and odd, then the value is also not same. We have seen that. Function value is also not same. We have proved this. That means what here? F of m not equal to f of m. X not equal to y. See what the second definition is what? X not equal to y. F of x is also not equal to f of y, right? So here what? M is even, n is odd. That means m not equal to n. So f of m is also not equal to f of n. Okay. Consider next example. Consider the function f from R to R defined by f of x is equal to x square plus x plus 1. Show that f is not onto. What do we mean by onto? Onto means what? Here R, here also R. Okay. Onto means what? Every element here has pre-image. That means if you take any y in the real number, there should exist belong to R such that f of x is equal to y. If this is true for every y, then if your function, that means what? Every element has an image. That means your range set is same as codomain, then the function will be onto. Now we see here, so you know that x square plus x plus 1, so it has a complex root, right? So that means what here, so suppose let 0 belong to R such that, let 0 belong to R. So 0 is in the codomain now. So what we will prove? 0 has no pre-image, right? So let x belong there, let there exist x belong to R such that f of x is equal to 0. So f of x is equal to 0 means what? X square plus x plus 1 is equal to 0. So now we know that this we can write this what? X plus I can write this twice x. So x plus 1 square minus x is equal to 0. Here, right? So that means what here? X plus 1 square is equal to x. So if you put x is equal to 0, imply that 1 is equal to 0. So this is not possible. Therefore, 0 do not belong to range of f. 0 do not belong to range of f. That means what? Here 0 is there, right? So it has no pre-image. 0 has no pre-image. So therefore f is not onto. Right? Otherwise what? You may also write this what? You may also write that instead of this. So you know that this is the quadratic equation. Right? So how to find the roots of the quadratic equation? X is equal to what? Plus or minus. What is that? X is equal to minus c. This is what? Ax square plus bx plus c is equal to 0. What are the roots of this equation? Minus b plus or minus root of b square minus 4ac upon twice a. This is the formula to find the square root of the quadratic equation. Okay. So now we will write this what? Everywhere ABC is 1 now here. So this is what? Minus 1 plus or minus root of b square is 1 minus 4ac, so minus 4 upon 2. So x is equal to minus 1 plus or minus root of minus 3 upon 2. So these do not belong to R. So that means what? There does not exist any x belongs to R such that f of x is equal to 0. That means what? This x does not exist. That means 0 has no pre-image. Right? So therefore, see here what we have written. There does not exist any x belong to R such that f of x is equal to, because this is a complex. Right? This is not possible. Right? That means what here? This has no roots. That means there does not exist any x belong to R such that f of x is equal to 0. So that means what here? F is not onto, because what? 0 is in the codomain which has no pre-image. So when we say that a function is onto, every element of the codomain has a pre-image. Right? So that means your range set is same as the codomain. So your 0 do not belong to the range set. That it is belong to codomain, but it is not in the range set. That means range set is not same as codomain. So that means this function is not onto. I hope that you understand all the things. Okay, so we stop here.